Good morning, good evening, and good afternoon. We are thrilled to have all of you here with us. It is 2 a.m. here in Redmond, Washington, and we are coming to you live. I wanted to introduce Kyle Weller, our Senior Product Manager for Azure Databricks, who will be talking to you about what's new on our roadmap, our innovations with Delta, and a few other exciting things. Our team is here standing by to take all of your questions, so please feel free to put them in the chat window. Without further ado, Kyle, take it away.
Thanks, Yatharth. Welcome to Microsoft Build 2020. I'm coming to you live from my bedroom. My wife is sleeping on the couch right now, so I can give this presentation, and I'm sure to be banished there tomorrow. I hope all of you are staying safe and, more importantly, staying sane out there. We're in this together, and I know that even these challenging times will soon pass. Here's a quick look at what we'll run through in our short time together today. As Yatharth mentioned, we'll go through a roadmap of what's new, what's coming. We're going to dive into Delta Lake, why Delta Lake is important to you, and we'll show you a real-time demo doing some analytics on some COVID-19 data with Azure Databricks and show you how Delta Lake can help you do that even faster. We'll save a lot of time for questions and answers at the end. So what I want you to do is put all your questions in the chat window that you have available. And then we'll gather these and even present and talk through some of these at the end as well. All right, let's start with what's new, what we've been developing, what we've released recently, and what's coming up soon. On the top, I want to talk about our AAD authentication with REST APIs, this public preview that I know many of you have been highly anticipating. With this, you can use user and service principal tokens to fully automate workspace creation through workspace and cluster creation without manually having to obtain a Databricks PAT token. Our Databricks Pools GA release allows you to achieve up to 7x faster cluster startup times and auto-scaling times. Our Databricks Container Services GA allows you to configure your cluster with your own containers that are pre-packaged with your data science libraries and dependencies for your complex environments. Databricks Runtime 7.0 beta with Apache Spark 3.0 preview. If you haven't read up on Apache Spark 3.0, you need to dive in and see what's coming. It's jam-packed with so many exciting and wonderful features. Things like adaptive query execution at runtime, dynamic partition pruning, enhanced deep learning support, so much more. Go read up about Apache Spark 3.0 and try it out on our Databricks Runtime 7.0. We also released 0.6.0 for Delta Lake. This enabled some dynamic file pruning turned on by default, which we see up to 8x performance in some cases. And we also added schema evolution and merge operations. Our Databricks Autoloader public preview gives you a more efficient way to process new data files incrementally as they arrive onto your cloud storage during ETL. Let's skip on down to the what's coming section. We are soon to release on our Azure US Government Cloud. This should come very shortly. Before the end of the year, we'll also be releasing onto our China cloud, and we will be receiving FedRAMP certification. We'll be adding a private link connection capability between our web app and APIs. And we're also adding in some AAD authentication, pass-through authentication with Power BI. I also want to include a special shout out for my colleagues over on the .NET team. You can now author Spark applications with .NET Core 3.1, C#, F#, and ML.NET. This is fully compatible with Spark 2.4 and 3.0. Use the short links below to learn more. You got aka.ms.net Databricks and aka.ms/.NET Spark. Go check those out to learn some more. Let's dive in to talk about Delta Lake and how Delta Lake can help bring reliability to your data lake. And we're gonna tee this up before I show you a demo. First off, some people get confused by the name at the beginning and think they have to store their data in a new location. This isn't true. You can keep your data in the same storage of your choosing, ADLS Gen 2, blob storage, etc. And you can think of Delta Lake more as a storage format technology. You can take data from any format, CSV, JSON, Avro, Parquet, etc., and upgrade this into the Delta format. When doing so, what we do under the hood is we save this data as version Parquet files, build a transaction log, and add additional indexes and stats. Let me tell you about some of the benefits. First off, think about the promise of a data lake, the central source of all data democratized, shared, and accessible by employees across your whole company. Traditional data lakes and Spark offer no concurrency capabilities, but because we have version files and a transaction log, we can promise ACID transactional guarantees and enable simultaneous concurrent reads and writes on all of your data. Another problem with traditional data lakes is that things start to get messy. Delta Lake offers various levels of schema enforcement and schema evolution control, allowing you to set guardrails, but still be flexible when you need it. We offer you efficient upserts with blazing fast and simple merge and insert commands. With version files, you have the ability to travel back in time and reproduce data or immediately roll back to a prior version of data without reprocessing. You can do this with simple select statements like select my data from this table as of a particular timestamp and reproduce that data exactly how it was at that timestamp. The next two benefits are uniquely available in Azure Databricks, and I'll show you on the next slide how you can achieve 100x performance with these features. Okay, everyone probably already knows the basics about partitioning and how you do this on low cardinality columns. You can partition by maybe one column, maybe two columns, but you have very diminishing returns as you increase from there. You're trying to aim for about a gig per partition when you do these partitioning. But now, in addition to the traditional partitioning that you're used to with Apache Spark, you also have this new Z-order capability. It allows you it's a technique that co-locates related information in the same set of files and enables a concept of data skipping. You do this on high cardinality columns, so now you have a multi-dimensional partition scheme between low cardinality columns and high cardinality columns. In addition, I also mentioned another feature uniquely available on Azure Databricks called Optimize. This command runs in the background to reorganize and compact your data in the perfect size files for high performance Spark compute. We have real customers using these best practices today and achieving up to 100x faster processing times versus open source Apache Spark that you might find available in other products. Okay, let's make this come alive. Let's switch over to a demo and show you how this works. I'm going to show you how Azure Databricks can quickly and easily run analytics on some COVID-19 data made accessible by Johns Hopkins University. At the end, I'll show you how leveraging Delta Lake can do it. Delta Lake to do it can speed up your queries by 20x, 25x, etc. This notebook is available on my personal GitHub. Use aka.ms/databricksbuild 2020. Keep in mind as we go through this, I'm not a scientist. I'm not an epidemiologist or an expert on this topic in any way, shape, or form. But hopefully there are some experts out there watching who can leverage this and make an impact on the global pandemic that we all find ourselves in today. Okay, I mentioned that this is available. This is made available by Johns Hopkins University. Also, this data set is accessible to all of you for free today. If you create an Azure Databricks workspace, behind the scenes, we also create a default storage account given to you. And in this default storage account, you have a whole bunch of data sets made available that you can play with and do some sample building with. So you see on the top here, there's a folder for COVID. This is where this data is being used for this demo today. So this simple %fs ls on the folder structure shows you what data is available. Now, all the code you can get, even these sub notebooks that I'm running, you can get this on the GitHub if you want to dive in and see exactly what's happening. But here it's basically ingesting a whole bunch of files, merging them together, cleaning this data up just a little bit, and merging some schemas from a variety of sources. You can imagine this data has been sourced from all around the world. So there's a little bit of cleanup that needs to be done to get things in the right order and state. But what I do in this ETL process is I create a view. There's View GHU, Johns Hopkins University Daily COVID. And if I switch over, remember our notebooks are multilingual here, so I can switch between languages of Python, Scala, SQL, R. I can switch over to SQL here, select everything from the table or from the view, and I see that I have a table which has the number of confirmed cases, the number of deaths for various countries and regions, states, provinces, counties, those kind of things. Let's make it come alive a little bit closer to home. I live in a county called King County, Washington State in the United States. And so if I select some data from here, from the view, and I'm looking in King County, Washington State, I can use the built-in visualization functions here to plot the total number of confirmed cases and the total number of deaths over time. And I can get this nice visualization. Let's do something a little bit more complex, though. We're going to normalize the data by per capita, per 100,000 people per capita. And then we're going to normalize, let me run this command here. And then we're going to normalize the time series. What we do is basically find the very first time that the COVID-19 virus was reported in a given region, and then we're going to line these up, do the date diff here and line up the dates so that we can have a day number counting. So we can say this is day 0 of reporting, this is day 1 of reporting. So we're normalizing both per capita and normalizing on the time series. And what we're able to do with this, this leverages an open source library, visualization library. You can pull in any of your favorite libraries from PyPI or other versioning places and build on top of them. So here under the hood, again, you can go to GitHub and see all of the code. I didn't want to put a whole bunch of spaghetti code on the screen for the demo, so to make it simple, I put it in this sub notebook. But what's going to load is the United States map, and it's going to be a heat map per county. A county is a subsection within each state in the United States. And we're going to see the relative number of cases and deaths per capita. The yellow to blue shading here, these are the confirmed cases, and the red circles are, unfortunately, the deaths that have occurred. And so you can see this really rich visualization that's built in here that we could create in the notebook. There's also a nice little slider that makes it a little more interactive. So I can start here at day number 100 of reporting and see what it looked like. And I can drag this along the screen. I know we can't see all of it in the screen at the same time here, but you can see how this pandemic has been progressing through time, and unfortunately how it's been growing to the point where it is today even. Let's take a pause and look at the time that it took for these queries to run. Up on top here, let's see the first visualization that we created. This one, it took me about 6.77 seconds to run. But notice there's this little idea bubble here. I skipped over this before, but if we click this idea bubble, watch out for these because they can help us out. It says that it thinks we can accelerate queries with Delta Lake. It noticed that this query contains a highly selective filter, and to improve the performance, we can convert this data to a Delta table and use optimize and Z order. The same principles that I went over before. So yeah, watch out for these idea bubbles. They can give us good tips. Let's try to follow the advice and see what happens. So I'm taking the same data, selecting all of it, and I'm writing it, .write.format delta. So normally here in your statement, you would say .write.format Parquet, CSV, JSON, Avro. I just changed one word and no other setup that's hidden in my other subfolders or anything to set this up for Delta. I say .write.format Delta, I do an overwrite, I partition, and I save it to a path that's on the default storage account given to me with my workspace. Now I can come in here and create a table for this, and it's using Delta. And then I'm going to optimize. I say optimize my table, and it does the magic behind the scenes, putting these in the perfect size files that Apache Spark loves to have for the highest performance. And then I'm going to run a Z order on the process state so that even within these files, it's ordered according to that process state. You can imagine then a query processor would, if it needs to select just a certain range of process states, it can access that data very fast. Doesn't have to seek or read through a bunch of files to find the right data. So let's run these commands. I omitted to run them. And after doing so, let's see the same exact query from before, selecting the data, but now from this Delta Lake table. And again, the same King County within Washington State. Let's see how fast this query takes to run after we've optimized. So we see the other commands are still running. Let's wait for them to complete. I forgot to run them as I was speaking. Once this table optimizes, gets all the data in the right size files, and then we Z order here, we'll see this command run. And I've already put it up in the titles, the giveaway, took the thunder away from the end result. But you'll see this run somewhere between 0.2, 0.4, 0.5. This one looks like it took up to 0.7. But I could run this a couple of times. It's pretty snappy in the response. Of course, it's a very simple, very basic query, so it shouldn't take much time at all. But here's the old query for reference. Again, the same code, right? The same select statement, except for the from. The from, we're not reading from the Delta table here. And so this is reading from, you know, I could be dealing with the small files problem here, where data is distributed on many small files that are scattered throughout my storage. And Apache Spark is not optimized for these scenarios. It wants to have a smaller number of larger files to deal with. And that's exactly what this optimize command was able to take care of for me. So this wraps up our demo. Hopefully it's clear to see just how easy it is to get started with Delta Lake. Change a few lines of code for immediate performance improvements, cost savings, and faster time to insights. With that, I want to pause and come back and move into Q&A. So hopefully there have been some good questions asked. Yatharth, I'll open it back up to you and you can pose some questions.
Wow, Kyle, that was amazing. Changing a few lines of code and getting a performance boost of up to 10x. That's mind-blowing, man.
Yep.
I just wonder if I could get that performance boost, I could get so much more done on a daily basis. So let's get to some of the questions. Kyle, you spoke a little bit about pools, and we have a question here around the price of pools.
Okay.
When we have Databricks pools, what do we pay for while those pools are warmed up?
Yeah, great question. So Databricks pools, the concept, I'll explain the concept just a little bit and then I'll get to the pricing aspect of it. So Databricks pools, the idea is to have faster cluster startup times and faster scaling when your cluster is auto-scaling and provisioning more nodes or releasing those nodes, have faster auto-scaling and faster start times. The way that we achieve this when analyzing the cluster startup time and finding the bottlenecks and where the longest pulls were, we saw that the longest period of time was acquiring these VMs from Azure. So Databricks pools, as you can imagine from the name, it keeps a pool of VMs that are alive, that are hot, and that are turned on and ready. And then when you go to create your cluster, it can grab these VMs from the pool very fast, decrease our cluster startup times by roughly 7x on average, and can be off and running from there. So now you can kind of do the math and thought process at this point that you have VMs that are alive and turned on. And so you will be paying for those VMs to be on. But when you think of your overall cost, Azure Databricks, you pay for what we call a DBU or Databricks unit, and you pay for VMs. You're not paying for any Databricks unit. The VM cost is much lower, but you do pay for these VMs to be alive, and you'll want to analyze is this worth it? Can I justify this extra cost? And for the extra performance benefit that I'm gaining. Some of the scenarios you might be considering for this are obviously for faster startup time. So if you have jobs that do not take a long duration to run, let's say your jobs only take a few minutes to run and you have many of these jobs and you want to run these jobs back to back, maybe you have many recurring back-to-back jobs that you want to run with pools, your job can start up very fast, execute the code, return those VMs back to the pool, and move to the next very quickly as well. So you might find that in some of these scenarios, the performance benefits will far outweigh the extra cost that may be incurred.
So what I'm hearing from you, Kyle, is that if I have a very high number of small jobs, then pools is going to significantly help speed up that process, save costs, and deliver much better performance.
That's right.
Is that correct?
That's right. You got it.
Great. Let's switch topics a little bit. Can you tell us about the Delta format and if it can be used in ADF directly to store data?
Sure. Great. So the Delta format, to start off with, is an open source technology. This has been open source for over a year. It has very wide adoption, even up to 75% of our customers today are using Delta Lake. And the Delta Lake open source project has been donated to the Linux Foundation. So there's wide adoption and community engagement and growth around Delta Lake as well. So then when you think of Delta Lake, or when you think of Azure Data Factory and how you would interact and use Delta Lake with Data Factory, there's a couple ways that this might happen. One is for Azure Data Factory allows you to create Databricks jobs and orchestrate Databricks jobs that you can read and write with the Delta Lake format. At this point in time, I don't believe that Data Factory supports with the copy command Delta Lake, but I think that's coming in the very near-term future.
Yeah, and while you were talking, Kyle, I just spoke to our friends in the Azure Data Factory team, and they tell me that it is going to come up this summer. So stay tuned for that, where you can load data directly into the Delta format using Azure Data Factory.
Yes.
There is another question that says, can you show how notebooks can be integrated into Git? I don't think we can show that live, but Kyle, can you talk a little bit about Git integration in notebooks?
Sure, I actually can show kind of where it surfaces in the UI. I won't be able to do like full end-to-end setup here on the demo, but in your workspace, the question was, let me make sure, I'll repeat it back just to make sure I heard it right, was how do you integrate the notebooks in Git? Is that what the question was?
Yes.
Okay, good. Yeah, so here within the UI itself, there's an option here where you can open up this revision history. And you can automatically link this. Let's see where I go on the clicks here. You can link this up to various sources like Git, Bitbucket, Azure DevOps. I forget all the various places that you can link it, but there's a bunch that are natively supported here. And you can come in and provide the path and the branch and the various details and link it up this way. I believe this is also possible via the APIs, so you could programmatically do that version link up. And then we also have documentation on how you can complete this kind of CI/CD workflow with any other tool. Let's say we didn't support it natively through our built-in version history linking here, but you can also leverage our APIs to do the same exports and loads into any other version control system that you want to hook up with.
Perfect. Thank you for that, Kyle. And we have a couple of questions on ADF and PAT token, but could you tell us a little bit about what's happening with PAT tokens? Like, are we going to continue to use them in our APIs, or have we made some changes there?
Yeah, great. Yeah, so I mentioned the very first thing on the roadmap. I can even back up, I think, to the roadmap slide and keep this slide up. It could be good for more Q&A as we go. Yeah, I mentioned the very first thing on here, how we enabled the AAD authentication with the REST APIs. And so if you think about where the Databricks PAT token, personal access token, is used, the majority of those places are for the API. And so with AAD authentication, you no longer have the need for the PAT tokens to use within the REST API. There is still some places where you may need the PAT tokens, and some of those places will be around Power BI. I mentioned down here, coming in the future, we will be adding pass-through AAD authentication in that realm. I can't remember all the other surface areas where the PAT token is still relevant, but the PAT token will remain relevant, and you can continue using it on the APIs. But now you have the option with this first public preview to also use AAD authentication.
Perfect. Thank you for that, Kyle. And just for our audience, we have about 5 minutes left, so we'll take 2 or 3 questions. Can you tell me, Kyle, a little bit about machine learning? Can you use Azure Databricks to do machine learning?
Awesome. Yes, that is one of the primary use cases for Azure Databricks. Obviously, Azure Databricks is a general purpose compute engine for processing big data, but it also comes built in with a lot of machine learning libraries and functionality to make the machine learning lifecycle management very easy for you. We have a tool called MLflow, and I'm sure you've already learned about from Build and other places about Azure machine learning as well. So we have a native integration between the MLflow and Azure machine learning APIs. These tools are aimed to help you manage your all the way from development of your machine learning models to training, tracking the run history, experimentation, and even where you're going to deploy these models at the end. So the full MLOps cycle can be managed together with MLflow and Azure Machine Learning. So you can pull in a wide variety of open source libraries, popular data science libraries, and train, build, deploy, score machine learning models within Azure Databricks itself.
All right, we'll take one last question, Kyle. You spoke about Delta, and your demo showed how Delta helps improve the performance. And I know a couple of folks are asking if they could try it out. Yep. I think the notebook's available to them. But could you also talk to us a little bit about the time travel feature in Delta?
Yeah, time travel. That's a good one. So I mentioned how under the hood, we keep Parquet files, and we version these Parquet files for Delta Lake. That's the actual format. If you cracked open the file and folders, or the folder and files underneath, you'll see they're truly Parquet files. We version these files and keep a transaction log handy. So then you can write queries such as select this data from this table as of. You can say as of a particular timestamp. And that's very powerful for a few reasons. One might be for data reproducibility. So we were just talking about machine learning. Sometimes you need to retrain a machine learning model, and you need to reproduce the same data in the same state that it was in when you trained previously. And to have real experimentation and to know that true delta. So you can do that with time travel. Another function would be for debugging. If data is constantly changing and evolving, and something might go wrong, or maybe some data was double pumped, or some other anomaly came in, you can travel back in time and see what happened. And then even another use case that this brings us to is immediate rollback capabilities. Imagine you could write a statement that says, select my data from here, from this table, table A, as of the past, as of a week ago or a month ago, whatever you want to choose. And then you could insert that into the same exact table. And so this allows for like an immediate rollback without additional reprocessing on top. Those are some of the great features that are enabled with time travel.
Perfect. Thank you so much for that, Kyle. And we're just out of time. I want to, on behalf of Kyle, me, and the rest of the team here, I want to thank everybody for joining us. We're going to do this session 2 more times. So, if you have more questions, please do join us again. Thank you very much, and have a good night.
Thank you.